Hello everyone, welcome back. Today we're going to be solving logarithmic equations, and we're also going to check for extraneous solutions at the end. Reminder that extraneous solutions are solutions that we end up getting from solving the equation that actually don't work if we plug them back into the original. The reason that in this situation we would need to check is because logarithms cannot take negative values, and so therefore any solutions that we end up getting that would result in our logarithms obtaining having a negative value that they're asked to take are not going to work and therefore would be extraneous solutions. But anyways, let's dive into it and we'll get to that in a little bit. Okay, so the first step we want to do here is we are going to combine the different terms that we have on the left. Okay, so we're going to end up with logarithm with base 5 of 3x times x plus 1, right? Because recall that when we add two logarithms with the same base, we combine what we're taking the logarithm to by multiplying together, and that's just going to be equal to 2. Therefore, logarithm base 5 of 3x squared plus 3x, if we use the distributive property, is equal to 2. And now we're going to switch this from logarithmic form to exponential form, right? So recall that to switch this to exponential form, we're going to take the base, which is 5, to the power of the answer, right? The answer when we're in logarithmic form is the power, or the exponent, is equal to what we're taking the logarithm of, which is 3x squared plus 3x. And now we just need to solve this. 5 squared is just 25, so 25 is equal to 3x squared plus 3x. So therefore 0 is equal to 3x squared plus 3x minus 25. Now we could either solve this by using the quadratic formula or by factoring. Now, in this situation, this looks like it would be a pretty big pain to factor, and also factoring doesn't always work as there aren't always actual answers we can obtain by factoring. And so I'm just going to go with the quadratic formula here. Recall the quadratic formula states that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 3 because that is the leading coefficient. B is 3 because 3 is the coefficient of x as well. And then C is for the constant. The constant in this case is negative 25. So let's plug all that in. Then we end up with x is equal to negative 3 plus or minus the square root of 9 minus 4ac all over 2a. And that is equal to negative 3 plus or minus the square root of, 9 plus 300, so 309 all over 6. And so there's two solutions, right? We have x1 is going to be equal to negative 3 plus the square root of 309 over 6. x2 is equal to negative 3 minus the square root of 309 over 6. Now we also need to check for extraneous solutions. Recall that the logarithms can't take a negative value. And so if either of these would result in the logarithm overall taking a negative value, either one of them or both of them potentially, then it's an extraneous solution. So let's take a look at this. So x1, we're going to get a decimal approximation in order to know if this is the case or not. So the square root of 309 is approximately 17.6. Then if we subtract 3 from that and then divide by 6 in our calculator, we get that x1 is approximately 2.43. And then for x2, if we do the same thing, if we take the negative version of the square root of 309 and then subtract 3 from that and then divide by 6, we get that it's approximately negative 3.43. So the question is, do not whether or not one or both of these values are negative, but would either of them result in our original equation not being applicable, right? Do either of them result in either log with a base 5 of 3x having a negative value, or log with a base 5 of x plus 1 having a negative value? And the answer is yes, right? If we plug in 2.43 to either of these, we get positive numbers, right? Because 3 times x1 would be 2.43 times 3, which is 7.29, which is a positive value. And then x1, I think it was minus 1. Oh no, it was plus 1. X1 plus 1 would just be equal to 3.43, which is also positive. Therefore, this is a valid solution, not an extraneous solution. Whereas if we do 3 times x2, we get a negative number, right? We get negative, let's see what number we actually get. Not that it really matters. Negative 10.29, which is a negative number, so therefore this is an extraneous solution. Or the other argument we could make is that x2 plus 1 is going to be negative 2.43, which is also a negative number that would be in our, in the brackets of our logarithm, which is also not allowed as well. Now, that said, we actually only have to have one of these values being negative in order to say this is an extraneous solution. So this one here is not an answer. This is an extraneous solution. And then this one here that I'm going to highlight in yellow, this is our actual real solution that actually does work when we plug it back into the original equation. Okay, well, that's all for that one. Let's do a second example. Okay, so first thing here is I'm going to use the multiplication property in order to multiply x plus 5 with 2x. So therefore we get logarithm base 3 of 2x times x plus 5 is equal to 4. So then we have that logarithm base 3 of 2x squared plus 10x is equal to 4. Then I'm going to switch this from logarithmic form to exponential form and get that 3 to the power of 4 is equal to 2x squared plus 10x. Now, 3 to the power 4 is the same as 81. Therefore, 0 is equal to 2x squared plus 10x minus 81. Now I'm going to apply the quadratic formula in order to solve this. Okay, so in this case, a is equal to 2, b is equal to 10, and c is equal to negative 81. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's see, that is equal to negative 10 plus or minus, let's see, 10 plus all of this, so 4 times 2 times 81 is going to be 648, and that's positive 648 plus 100 is going to be 748 in our square root sign, all over 4. And that is not a perfect square. And then we are going to write down x1 and x2. So there's two possible answers here. Negative 10 plus the square root of 748 divided by 4, or x2 is the other possible solution here, that negative 10 minus the square root of 748 over 4. Now we have to get the decimal approximations because we want to know if either or both of these could be extraneous solutions here. So let's do that. Let's take the square root of 748, which is going to be approximately 27.35. Then I'm going to subtract 10 and then divide by 4. So therefore, x1 is equal to approximately 4.34, and x2 is equal to approximately, well, let's see. Okay, let's take the negative version of the square root of 748 in our calculator, and then subtract 10, and then divide by 4. And if we do that, we get negative 9.34 approximately for that one. And now going back to our original we need to know is if either x plus 5 for either of these values or 2x for either of these values gets us something negative, because if it does, then that's not a real solution. That's an extraneous solution that doesn't actually work here. However, if both of these end up being positive, then we're good. Okay, so x1 plus 5 is equal to 9.34, and that is a positive number, and so we're good there. And then 2 times x1 is equal to 4.34 times 2, which is 8.68, which is also positive. Therefore, this answer here, x1, is indeed a real answer. However, x2 plus 5 is going to be equal to negative 4.34, which is a negative answer. So just based on that alone, we can say this is an extraneous solution. Okay. Now, that said, another argument that we could make to prove that it's an extraneous solution is that 2 times x2 actually is also negative, because it's going to be negative 18.68 approximately, which is still negative, and so therefore this is an extraneous solution. However, keep in mind, we actually don't have to show both of these. We only have to show that one of these is negative to show that it's an extraneous solution. To prove that something is not an extraneous solution, though, we do have to try for both and make sure both are positive, right? Because if both are positive, then it's a real solution, not an extraneous one. And if either or both are negative, that makes it an extraneous solution, since neither of those logarithms can take any negative values. All right, well, that's all for this one. If you have any questions, feel free to leave them in the comment section, and we'll see you for the next one.